Okay, so we just did strategies for simplifying trigonomic expressions. Now we're going to do some more strategies. Now those of you who just did the first 6 strategies, you had some practice problems on the back, so you hope you did those. Now we're going to do some more strategies. Okay, so here's a couple more. These are maybe a little more complicated, but not too bad. All right, so hopefully the first thing that comes to your mind as you look, let me focus that a little bit, as you look at this first problem is you see 2 binomial expressions. Hopefully the first thing that comes to your mind is foiling, F-O-I-L. First, outer, inner, last. So let's do that. 1 times 1 is 1. The outer terms is plus cosine theta. The inner terms minus cosine theta. And the last terms are minus cosine squared theta. Now, anytime you see a positive and negative, we know that these 2 are going to drop out. So the next time we see this positive and negative, we don't even have to do that. And it just becomes 1 minus cosine squared theta. Now hopefully that brings to mind our trigonomic identities, and we recognize that 1 minus cosine squared is what? Well, that is equal to the sine squared of theta. Hopefully you have your trigonomic identities right next to you and you recognize that. Okay, we have the sine squared of theta. So if you don't, get that right next to you. Okay, so let's do it again. This is binomials. Let's first, outer, inner, last. So we have secant of theta first. Secant squared theta, outer, inner, we don't have to write those, minus 1. What is we know that the inner terms and outer are going to cancel. What is secant squared minus 1? Well, that is the tangent squared of x from our Pythagorean identities. Okay, there we go. All right, so the first thing we can do is multiply. We can multiply. All right, the second thing we can do is we can factor. So looking at problem number 3, cosine squared of x minus 4. How can we factor that? Well, I recognize that that is the difference of 2 squares. It's subtraction, it's the difference of 2 squares. So I can say that that is the cosine of x plus 2 times the cosine of x minus 2. And then looking at the bottom, I know that that's just the cosine of x plus 2. So what happens here? Those will cross out, and that leaves me with the cosine of x minus 2. So that is a simplified function. Okay, remember my goal is to simplify. I could solve that at this point, but we're just simplifying, so let's leave that for now. Okay, now I'm factoring, so look at number 4, and what do I have here? Well, I have the same thing. I have the difference of 2 perfect squares. So let's do that same thing. 1 plus the tangent of x times 1 minus the tangent of x. And then that's going to allow us to factor 1 minus the tangent of x on the bottom. Those 2 are going to cross out, leaving me with 1 plus the tangent of x. All right. Now, let's go on. Now here, number 5, I can factor again. What can I factor here? Well, I see that both terms have a tangent squared of x, and I can pull out that from both terms. Tangent squared of x, if I divide it out of both terms, I'm left with 1 minus the sine squared of x. So now I've got these 2 terms. Well, what is 1 minus the sine squared of x? Well, thinking of Pythagorean identities, excuse me, I realize that I can substitute again tan squared of x times cosine squared of x. Okay, well, I can still go further. What is the tangent squared? Well, I can write that as sine squared of x over the cosine squared of x times the cosine squared of x, and those will cancel out, leaving me with the sine squared of x. And I have simplified as far as I can go. All right, let's do it again. So number 6, what can I pull out of both terms? A sine of x. So I pull out, factor out, divide out a sine of x out of both terms. When I divide it out of this term, I'm left with a 1 minus the cosine squared of x. Okay, what is 1 minus the cosine squared? Well, from Pythagorean identities, that is sine of x times sine squared of x. Okay, so I can simplify this one step further, right? I can multiply those together to get sine cubed of x. So that's what can happen when we factor. All right, now our last strategy is to combine fractions. So looking at number 7, I see that I have 1 plus the sine of x and 1 minus the sine of x. I can combine these fractions to I want to combine this fraction and this fraction. So it's going to take some doing. It's going to be a little bit tedious, but here we go. Okay, so what I'm going to do is I don't have common denominators, I have to get them. So what I have to do is my common denominator is going to be 1 times 1 minus the sine of x times 1 plus the sine of x. So if I want to get that as my common denominator, so this is what I want as my common denominator. 1 minus the sine of x times 1 plus the sine of x. That's what I want as my common denominator. So what do I do to get that in the numerator? So I have to multiply. To get this as the denominator, I need to multiply this by this. So I have to multiply the numerator by this, 1 minus the sine of x. So this becomes the numerator. And if I want to get this in the denominator, I multiply the denominator times 1 plus the sine of x. And I multiply the numerator 1 times 1 plus the sine of x. Okay, so now what do? This numerator becomes 1 minus the sine of x. And then we subtract, now this in the numerator, minus 1 plus the sine of x. So now I have this minus this. Now I just have to combine all those terms. So let's combine them. 1 minus 1, what happens? Well, those two terms, I'll use a different color, cancel out because 1 minus 1 is 0. But now I have negative sine of x minus the sine of x, because this negative distributes, right? The negative distributed to the 1 and the negative distributes to the negative sine of x. So now I have negative 2 sine of x over my denominator. Now I can combine my denominator. 1 times 1 is 1. Now I have, I'm going to FOIL this out. First, outer, inner. My outer and inner terms drop out, minus sine squared of x. Now, what does this become? This becomes negative 2 sine of x over, what is 1 minus the sine squared of x? According to Pythagorean identities, well, that is cosine squared of x. Now, we can further simplify this into negative 2 times the sine of x over the cosine of x. We could take one of those cosines times what's left, 1 over the cosine of x. So I'm running out of room here, but this is going to be negative 2. What is the sine of x over the cosine of x? Well, that's tangent of x. What's 1 over the cosine of x? That's the secant of x. So this is my final answer on Jeopardy. Okay, there we go. That was a bit of work, but we got it done. Okay, so now let's go to number 8. what is the common denominator between cosine of x and sine of x? Well, it is cosine of x, sine of x. You just combine them. So the common denominator is cosine x, sine x. That's what I'm looking for. So what do? I multiply this first term by sine. I need a sine x in the denominator over here, so I've got to multiply the numerator by sine x. So what is sine x times sine x is, keep that, sine squared x. Okay, well, in the second term, in order to get a sine x and a cosine x in the denominator, I have to multiply by cosine x. Okay, so this is going to be plus cosine x times cosine x, cosine squared x. Okay, so now I can just add the numerator. What is sine squared x plus cosine squared x? Well, that is 1 over cosine x times sine x. Okay, we can simplify this one more time. What is 1 over the cosine of x? Well, that is the secant of x. What is 1 over the sine of x? Well, that is cosecant x. There we go. All right. So, combining fractions again. Sometimes when I'm working with fractions, I like to see it, both of them have fractions. It's easier for me to see it if I see both in terms of fractions. So I have secant of x over 1 minus the tangent squared of x over the secant. So what is the common denominator? Well, the common denominator would be the secant of x. So I need this to be a secant. So if I want this to be a secant, what do I have to multiply the numerator by? Well, the secant of x. So this equals, I need a my common denominator is the secant of x. So secant, it's going to be secant squared of x minus the tangent squared of x. So how can we simplify this further? Well, let's think about our Pythagorean identity. So sometimes when I know it has something to do with both of those. So what I like to do when I'm looking at those, I write it out. I say, okay, I know the identity, let's write it down here at the bottom, is 1 plus the tangent squared equals the secant squared. So how does that work? Well, if I subtracted the tangent from both sides, tangent squared x minus the tangent squared x, what would 1 equal? The tangents would cross out and I would get 1 equals the secant squared x minus the tangent squared x. Okay, so the secant squared minus the tangent squared equals 1. So always go back to your Pythagorean identities and see if you can manipulate things to get some substitution. And yes, here I can. So this equals 1 over, I can substitute this for 1. This is substitute for 1 over the secant of x. But I'm still not done, right? Because I can then, what is 1 over the secant x? Well, it's simply the cosine of x. Okay. All right, one more. We have cosine squared of x over cotangent of x minus cotangent of x, and let's put it over 1. Well, what is my common denominator? Well, my common denominator is going to be the cotangent of x. What do I have to multiply this by? The cotangent of x if I want to get common denominators. So that is a common denominator of cotangent of x. So this is the cosecant squared of x minus the, minus the cotangent squared of x. Well, would this work in one of our Pythagorean identities? Let's work it out here on the bottom. What's my Pythagorean identity? Well, my Pythagorean identity is 1 plus the cotangent squared of x equals the cosecant squared of x. So what does 1 equal? 1 equals cosecant squared of x, subtract cotangent from both sides, minus the cotangent squared of x. Okay, I can make that substitution, so I will. This equals 1. So 1 over the cotangent of x, which equals, what's the reciprocal of 1 over the cotangent? It's simply the tangent of x. Okay, and I have made my simplification. All right, all your strategies right there.